Hello, so let's talk about acceleration and what do we do with it? Well, first of all, what is it? Acceleration is the change in speed. Previously we said that constant motion is the change in position, but today acceleration means the change in speed, the equal amount of change in speed. And we describe it with the following expression: a as acceleration will be equal to delta v over delta t. Well, delta v means the change in speed and delta t means the change in time. So as you can see, if a car changes speed faster, then it will of course have a greater acceleration. And of course, if it changes the same amount of acceleration in a shorter period of time, then of course it's also going to have a greater acceleration. So let's say in this small example that here the acceleration will be 2 meters per second per second. Well, first of all, what this 2 meters per second means? Well, this means that this red car will have 2 meters per second increase in velocity over 1 second. So as 1 second passes, the car's velocity will increase with 2 meters per second. So let's say we have like the same car here, but we documented the car's speed in the first second and the third second since we started accelerating with the car, and we measured its acceleration. And what we saw was as the first second passed, the car's speed was 2 meters per second. After the second it was 4 meters per second. And after the third second, it was 6 meters per second. As you can see the acceleration here, as time passes, the car's velocity will increase. And we also have like 3 graphs which describes this acceleration. Well, hopefully you saw all 3 of these graphs. The first of all is with acceleration and time. You can see that with this example, with normally with acceleration, as we see in every kind of example mainly, or at least in high school, that the acceleration is constant, so it will be a constant graphs, as you can see it. It won't change, the acceleration will be the same, any time can pass, it will be the same. If we move on to the next one in the center, it's going to tell the speed increase over time. And as we saw in the previous example, that as time passed, really speed increased constantly and slowly but surely, but it got greater and greater. And the third graph will tell us the distance our car took over t period of time. And as you can see, it's exponentially growing, because as the speed increases, what speed means is that it's having a greater change in distance, so it's going to take more and more distance over time. So if we wait longer, more distance will be taken, and if we even wait even longer, even more distance will be taken. So that's why it's growing exponentially. But among these 3 graphs, let's look at the center one. You hopefully observed that under this graph, the area was marked with light blue color, and I'll tell you why. So as you can see that under this line, we have like an area, which will definitely tell us something. But first of all, let's look at another example to understand it better. What is velocity? Well, velocity will be s over t, as we described it in the previous video. And if you want to describe it with this kind of graph, the change in velocity over time, we can see that in constant motion, that here the velocity is not changing. So it's like similar to the first graph. It's almost the same, but we write velocity instead of acceleration. So velocity will be the same. What we can realize that under this area I marked with light blue color, that it has a rectangle, and this rectangle tells us something. But if we look closer, if we look at the equation, and let's say we do something with it, we multiply both sides with t, we will get that s will be equal to v times t. And what we can realize that if we look at the graph, and if we know both values for velocity and time, and if we multiply each other, we get actually the distance. But if we look at it with geometric eyes, we can see that in this rectangle, if we multiply the sides with each other, we actually get the rectangle's area. So as you can see here in the graph, the rectangle's area will be the amount of distance it took. So as you can see that to get the distance it took under constant motion, we have to multiply v velocity with time. The same with the graph. If we want to get the area under the line, we have to multiply the velocity value with the time. And that's how we get our distance. And let's look at back the center graph. Well, it's not a rectangle, it's actually a triangle, but it's no big deal to us. We can still describe it. So the distance will be equal under the line. And so what is the area? What is this triangle's area? Well, what do we know about the triangle? Well, a triangle's side multiplied by the side's height divided by 2, we will actually get the triangle's area. So of course in this case we have to multiply, as you can see, one of the sides. Let's see, the one of the side is t with peak. We multiply it with the v side, so we multiply it with v value, and we divide it by 2, and that's how we get the distance it took with acceleration. But we can further do something with this equation to make it easier, because mainly we will not get the current amount of velocity, but we will mainly get the acceleration in examples. So as we know and remember that acceleration will be v over t, velocity divided by time, and we have these two equations, and if we look at this acceleration equation, if we multiply both sides with t, we actually get that v will be equal to acceleration times time. And if we put this acceleration times time into the other equation, the distance equation, we will get that the distance will be equal to the acceleration times the time square divided by 2. Wow, this is a really useful formula which most of you will definitely use in examples. Well, hopefully this video deepened your understanding in acceleration, and see you next time.